Hello, Keith Rucker here at VintageMachinery.org. Guys, today back working on the horizontal boring mill, and we're working on this problem we got with the cross slide screw for the table. When I got the machine, the little spline on the end of the handle that's used to crank it to move the cross slide table back and forth had been kind of stripped off and repaired, honestly, poorly, and we want to do a better job of repairing this. So that's what we're going to be working on today, kind of getting this thing ready to go. I need to get a blank turned down on the lathe so that we can go in here and actually cut the spline that needs to go on it on the horizontal milling machine, and then do a weld repair and then finish this whole thing up. Let me zoom you in here, kind of show you what we got to work with, and let's talk about our game plan and we'll get at it. So this is the cross slide lead screw here, the end of it, and you can see what we're dealing with. It has a spline on it, kind of like this one here, that's designed for a handle to go up onto, engage those slots, and that's what you turn it with. This one here looks like at some point in time had stripped off, broken off, whatever. It had been repaired, and but not very well. You really weren't able to use this handle. They had a separate handle that they kind of put together to make it work, and it worked. You know, I'm not going to get onto them too hard because their solution worked, but I really want to get this back closer to the original setup and basically recreate the spline. So here's the game plan. I'm going to turn a new piece, a new end on this that has the part that the handle slides up on. So I'll have the step here. We're going to machine the spline into it, and then we're going to just cut this piece off, and we're going to weld the new piece back on there together, and then turn it all down, get everything trued up or whatever, but hopefully just basically put a brand new end on this shaft. That's kind of my game plan. And the first step is we need to make our blank that we're going to weld on here before we do anything else. So that's what we're going to be working on. I've kind of got a drawing here. This end down here is basically 7/8 of an inch thick. This diameter is 1 inch 560 thousandths. It's kind of an oddball. This actually has a metric thrust bearing that goes on it, so I think that this is actually a metric measurement, whereas the other piece over here is 1.5 inches, so this is a little bit larger. No big deal. We'll make it where it matches. That's all that really matters here. So I'm going to be turning out just a blank, and then we'll get over on the horizontal milling machine to cut the spline into it. I'm going to probably turn this outside diameter here a little bit larger than the final, and then what we'll do is after we weld it all together, we'll turn it on the lathe to make everything match up just perfectly, so we're not having to worry if our weld is maybe off just a little bit. We'll true it all up in the final step. Is kind of the game plan there. So anyway, let's get at it. All right, guys, I just got a piece of random stock over here in the lathe, and you know, this has obviously been used for something in the past, who knows what, but it's an oversized 1 inch 860 thousandths. I need to get it down to about 1 inch 5/8. I'm going to turn this to 1 inch 5/8 just to, that'll give me a little bit of clearance room whenever we turn it up to the final thing. And also need to turn that little stem on the end. Again, I'm going to make it a little bit oversized. 875 is what it's measuring, which is 7/8. We'll probably go up to about 15/16 or something like that. Just to, again, we'll clean it up once we get everything welded together. So got it over here. I'm going to start, face the end, put a center in here, and turn this thing out. All right, got a little run out in it, but no big deal. We'll turn it out, get it running true to the part here. Right now, we just want to get this shape roughed out to where we want it. I think this will get it here. All right, let's put a center in there. Got a center drill here. And we'll come in there and put a center in that we can put some support out here. There we go, that'll do it. And we got a live center here. That'll give us our support. Come in here and touch off, and yes, we do have some run out there. 4, 6, 8. I'm gonna take about 100 thousandths off the total diameter. Get that run out turned out there. Get a good measurement, and we'll get this turned down. We're gonna go to 1 5/8, 1 inch .625. I'm gonna get a measurement on this and put it in my digital readout so we can kind of keep track of where we're at. We're at 1 inch 782 thousandths. 1.782. All right, we're going to 625. We'll just do 100 thou at a time here and knock it out. All right, this should be roughly to our diameter we're looking for. And again, this is oversized, so I'm not worried about hitting a specific number. It just needs to be close. We'll have more metal we can take off once we get it all welded up. And that's measuring perfect, 625. We will now turn in, what is it, 2.5 inches from the end, and we're going to, I'm going to go to 9375, I think is what we'll do on that. So what I'm going to do here, I'm going to come in and just kind of touch off on that end. I'm going to zero my Z-axis. I'm going to go in 2.5 inches, just reading it off the digital readout, which is, let's see, right there. And I'm gonna just come in here and make a, I like to have a visual mark while I'm turning. There we go. And we'll turn another 100 thou out of there. All right, we are going to go to 9375 right there. This is not a critical measurement, so I'm just reading it right off the digital readout. We should have a good 40, 50 thousandths to clean up after we get this welded on there on the stem, as well as on the main body. So this should be all we're going to do on the turning after this bit right here, just getting this roughed out. Break some edges, but that'll be about it. All right, let's get, we'll go up to that shoulder, and then we'll face out on that. Get a nice square shoulder there. Look at there. I mean, it's right on the money, 375. Of course, that part's hot, so when it cools down, it'll shrink a little bit, but it's turning straight off the digital readout there. Come in here and just break that edge. I'm gonna chamfer this one a little bit heavier, about like that. And our turning is done. We'll let that cool off a little bit and get it ready to go to the horizontal mill. Guys, I about got my horizontal mill machine set up here to make my first cuts in this little arbor that we're gonna make. And because we're gonna have to do the final cut using a single point cutter, just a piece of ground high-speed steel going around and around, I decided that I'm gonna make my first pass here using a regular cutter and try to remove as much material out of that groove as I can, and then we'll come back and clean it up. Still going to be taking a good bit of material out of there, but at least we'll have part of that material removed. So I've got a cutter here that's a little bit narrower in the bottom than what we're going to end up with, and we're just going to go ahead and make those cuts. Now we're making 7 cuts per revolution on this piece of work here. So I've got my dividing head set up to do 7 partitions, and to do that I'm going to do 5 full turns of the dividing head, and then I think that's 35 pins if I remember right. Anyway, I've already tested it out. I looked it up in the book to see what we need to do for 7 divisions, and that was one of the combinations it gave me on this particular plate. So that will help me do my divisions. Like I said, 7 divisions, and once we kind of get this thing roughed out, we'll switch over to the other arbor, and we'll have to grind a cutter to cut that profile, and we'll come back and finish cutting everything. So what I'm going to basically do here is the depth is just going to kind of more or less touch off on this arbor on this side, the small side, and I've got a line mark there. I don't want to go past that point, which is more or less how deep the original went. I'll probably try to stop it just a little bit short of that line, and then on the next round we'll clean up right to it and get to the depth there. So anyway, got the mill machine set up. Let's see if we can make some cuts here. All right, we're going to start by raising our table up until I just touch that shaft up underneath the bottom there. And I hear it right there. That's going to be my 0. And let's see what happens here. I've got my RPM set on 125 RPM, which is what I calculate for that particular size cutter to get the right surface feed. My feed rate right now is 5 7/8 inches per minute, and we'll play around with that. Let's let it feed and see what happens. All right. Here's our first pass, and we will rotate our part around here. 1, 2, 3, 4, 5. There we go. Make our next pass. All right, we're going to index this around, starting here. 1, 2, 3, 4, 5, and we'll come around to that pinhole, lock our table down, and we'll feed in. I did slow the feed rate down just a touch. There we go. One, 2, 3, 4, 5. And cut. One, 2, 3, 4, 5, and there we go. Let's cut her out. One, 2, 3, 4, 5. one more cut. 1, 2, 3, 4, 5. And right there. And this should be the final cut with this cutter. All right, we're gonna change setups here and get our other cutter ready to go to make the final profile. All right, bringing you back here, I think we're ready to go ahead and start making our next cuts. And I've got my custom bar here that's made to hold a piece of high-speed steel. And I ground the profile on there. I just ground that by hand over on the grinder using an angle gauge. I didn't really show the process, but I mean, that's just basic tool grinding. Got it where it's almost, I mean, it's really a perfect match going over to the original. And that's what we're going to use to widen that out and get that tapered side on the sides. Now let me zoom you out and kind of show you the whole setup here. So again, you can see the bar in here. Everything's mounted up, everything's tight, everything's good. And when we fire the machine up, that cutter's just going to be turning like such. So it's basically a one-tooth cutter, and it'll work fine. We just need to slow our feed rate down very slow. And I've got my feed rate set on the slowest that I can go, which is about a ½ inch per minute. And we're gonna see if we can run through there and open that profile up and get us what we want. So let's go over here and give it a try. All right, here goes nothing. I've got my depth set. We're gonna start feeding this in and see what it sounds like. It is feeding very slowly. We haven't quite made contact yet. I saw a chip come off there. So we are starting to go in there. So far, so good. And that's the full depth. That's right where I want it. Let's back out. I want to check this cut out real quick. All right, I'm going to go just a tad bit deeper here. Perfect. All right, we're gonna index and make our next cut. 1, 2, 3, 4, 5. And there, that should index us around to the next one here. All right, coming into cut number 3 here. And let this one roll on through. Just taking my time. I'm not in a big hurry. We've only got 7 of these cuts to make. Not trying to push this cutter any harder than I have to. This isn't really the ideal way of doing it, but for a one-off job like this, it beats spending a bunch of money having a custom cutter ground when we can just grind a custom piece of high-speed steel right here in the shop and get by with what we got. So anyway, we got this cut coming on through. Keep it lubed up good. When it gets kind of to the back of that cut, it's really making a pretty solid cut through there, but where we relieved out most of that, it's really making this cut a lot easier. You can hear how much harder it's working right there when it's making a full depth cut. it's doing it, and it probably would do it just fine, but this is a lot easier. And there's the end of the cut, and we'll back out. 1, 2, 3, 4, 5. One, 2, 3, 4, 5, and my partial. And let's cut another one. This one should be the last one to go through here. Let's take a look at what we got here. I'm pretty happy with how that turned out. I think it's going to work just fine. So just a couple of things to note. Remember, the outside diameter is still a little bit large. This diameter is a little bit large. We will turn that down once we weld it onto the other piece, just so that everything runs nice and true. So I did make that purposely a little bit oversized. It looks like everything's going to work fine just like that, though. I can't really put my wrench up on it until I get this end turned down to test fit it, but I went over and have looked at it real close, and it looks like it's going to work just fine. So I'm not too worried about that right now. So anyway, that came out pretty good. A little bit rough in the bottom with that single point cutter. I don't know if you can see the little bit of a rough mark down in the bottom, but for the job that we're doing here, it's not going to matter one little bit. So I'm not too worried about that either. I think for a quick and dirty solution to the problem, I think that it's going to do just fine. So there we go. One part. We're ready to get this ready to prepped up and weld up to the other piece, and then get it all turned down. But I think that's going to wrap up this video right here. Well, there we go. A little bit of fun over here on the horizontal milling machine, doing some turning with the dividing head, making custom cutters. Just all kinds of fun stuff. Things you can do in a machine shop. If you need something, you ain't got it, just make it. That's what it's all about here. So this is ready. We're going to go ahead and we'll finish getting this prepped up and ready to go on to that other part, get it welded up and get it turned down and final machined and everything else. But I think this is going to work just fine. So I'm really excited and ready to get that cross slide lead screw all finished up so that we can put the whole saddle back together over there on the horizontal boring mill. So with that, guys, that's going to be a wrap. As always, thank you so much for watching. Please subscribe to the channel if you haven't already. Thumbs up, comments, greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. And as always, a big thank you to my Patreon supporters, as well as anybody else who has supported the site. It is greatly, greatly appreciated, and we couldn't do all this without your help. And with that, guys, we'll catch you on the next video. Again, thanks for watching.